Mountains, physical features that make their own climate. Where is this happening? In and near high mountains. Some of these regions are highlighted in brown on this map. What is happening? Mountains make their own climate. Why is this happening? Going up means it's colder. There's usually more rain or snow, and complex rocks, slopes that get different sun angles, etc. The highest mountains are formed when crustal plates are moving together. These lines are indicated by small circles on this map. There are also areas that have a lot of strong earthquakes. Earthquakes are represented by stars on this map. Going up a high mountain is like traveling towards the North or South Pole. The air gets about 4 or 5 degrees colder for every 1,000 feet you go up. Look at this chart. Our yellow callout is labeled rainforest and represents where rainforests can occur. Here, the yellow callout is showing you where deciduous forests occur. Here, we're showing you where boreal forest occurs. Here, we're showing you where the tundra occurs. And here, we're showing you where the ice caps are. There's one big difference. There is no mid-trip desert. In fact, rainfall usually increases as you go up a mountain, up to a point. This picture from western Colorado shows 4 different elevation zones. Here, we're highlighting a dry valley with an elevation of 7,000 feet, with salty soils and a hayfield that needs irrigation. Here, we're highlighting a cool forest with an elevation of 8,000 feet, with small pine trees that can tolerate dry conditions. Here, we're highlighting a cold forest, elevation 10,000 feet, with spruce and fir trees like the boreal forest in Canada. Here, we're highlighting treeless tundra with an elevation of 12,000 feet, with bare rock and patches of snow that looks like northern Alaska. This picture from Wyoming shows how mountains can also make different microclimates. Here we're highlighting treeless tundra and snow on some very high peaks in the distance. Here we're highlighting desert shrubs on slopes that face south. These slopes can get more direct sun, which makes them warmer and drier. Here we're highlighting a forest of needle-leaf trees on the slopes that face north, get less sun, and are cooler. This picture from farther north shows how mountains can have different soil climates. Different rocks make soils that have different ability to hold heat or water. This picture shows how mountains can block the wind or force it to go through gaps between peaks. Good places for wind generators. Here's a concept diagram of mountain climate. The cause is the decrease in temperature with elevation. The effects include latitude zones, more rain and/or snow, warmer south-facing slopes, and colder north-facing slopes, changing wind patterns, and abrupt soil differences. Now we're going to talk about 2 examples of the effect of mountains on climate. Mesa Verde is a famous place in the Four Corners region. This is the only place in the U.S. where 4 states meet: Arizona, New Mexico, Colorado, and Utah. The Mesa is an isolated mountain surrounded by a large desert. There are 2 reasons for the dry climate: tropical subsidence and a rain shadow effect. Long before Columbus sailed to America, people built houses in shallow caves near the top of this mesa. The surrounding desert helped protect them from enemies. Some climate measurements can help us understand how people could live in this part of the region that some people call the Desert Southwest. 1 row of numbers are for Mesa Verde. The other row is for Zeeland, a small town near the eastern shore of Lake Michigan. Can you tell which is which? I'm not sure I could either. Now the numbers show average amount of snow that each place gets in each month of the year. Can you tell which is which? This is the effect of elevation. The elevation of Mesa Verde is about 8,000 feet. As a result, it is 30 to 40 degrees cooler than Yuma, a desert city next to the Colorado River in southern Arizona. In effect, the mountain makes its own climate. As a result, an old settlement in the desert Southwest actually has a climate much like a town in Michigan, with a long, cold winter and a lot of snow. The next example comes from a state that looks like these 4 pictures. Part of this state is a cool grassland. It looks like Wyoming or Montana with cowboys and herds of cattle. Part of the state is a hot rainforest. It looks like Puerto Rico with misty waterfalls and plantations of tropical fruits. Part of the state is a dry desert. It looks like Arizona with steep canyons, bare rocks, and desert shrubs. Part of the state is cold and snowy. It looks like Alaska with bare rocks, windswept ice, and very few plants. Where do you think this could be? All of these pictures were taken in Hawaii. These islands are at a latitude of 19 to 21 degrees north. That's right in the path of the northeasterly trade winds. The trade winds are part of a system that starts with instability near the equator and includes subsidence near the tropic lines. Here's Hawaii, where the wind blows from the northeast almost all of the time. This picture of Honolulu tells the story. Here I'm looking north from Diamond Head, a small volcanic crater near Waikiki Beach on the southwest side of the island. This is in the rain shadows of the mountains. This crater is full of desert shrubs because this part of the island gets less than 20 inches of rain. This apartment building is at the foot of a mountain and gets about 40 inches of rain. As you go higher in the valley, the amount of rain increases about 5 inches every block. The top of the mountain gets nearly 200 inches of rain. Remember, the wind is coming from that direction. The slopes on either side are covered with rainforest. The trade winds push air up on that side, which makes clouds and rain. Other islands are geologically younger. They have higher mountains, which are steeper, much colder, and often covered in snow. All of these different environments are effects of one powerful cause. Mountains make their own climate at different elevations on different slopes with different rocks.